This is A2Pure Maths. We're in section 4 integration. This is the second of our videos on integration. Again, we're just looking at some of the standard integrals as we try to work through and just thinking about them as a backwards differentiation. So a couple of things, if you remember, if you differentiated e to the ax plus b, you ended up with e to the ax plus b multiplied by a, because if you take the ax plus b out as a u, and you're using the chain rule, that a would then come to the front. So we can use that backwards again to our advantage then in terms of dealing with integration. The other one, and this is tremendous applications in integration, is the ln one. So if you differentiate ln ax plus b, what you end up with is the ax plus b on the bottom of the quotient, and then this differentiate, it's a differentiate the x plus b, it's on the top, and there's plenty of uses for that then in terms of integration of quotients and things, and they appear all the time. So let's take a look at a couple of examples and see if we can get them sussed out. The first one is the integral of 1 over 6x plus 2. You could just use the wee formula up there, but the way I generally think about it is if you differentiate the bottom line, can we make it into the top line? And when we can, if we differentiate the bottom line here, we get a 6, and I think to myself, can I convert this into a 6 by taking a constant out the front and then try and suss out then from there. So here we go. So I would rewrite this as a 6th integral of 6x plus 2 dx. And what I try to do, and it makes more sense in my head to do it this way, is if you differentiate the bottom line and you get the top line, then it's a straight ln integration. So in that case, we can just stick the answer straight in. So it's going to be then a 6th ln 6x plus 2 plus c. Nice and straightforward. If you can manipulate this in some way, so whenever you differentiate the bottom, you get the top, then it's a straight ln integration. And that's all we need to do to work out then from there. Let's see if we look at our second example. This one's a wee bit tougher and requires a bit of thought. A wee bit out of focus. I think there we are. So I'm going to rewrite this and not do too much at the start, but bring this up to the top. So it's 4x plus 3 to the minus 3 dx. That's what we're trying to integrate here. I'm trying to change the focus because it keeps moving in and out of me here. Let's see if that'll improve things. Sorry about that. So I want to consider a differentiation, and it's going to make this one work. So I'm going to look at d by dx of 4x plus 3 to the power of minus 2. Because let's see what we get if we differentiate this. If we differentiate this, the minus 2 comes to the front, and then it's multiplied by the bracket differentiated. So it's a minus 2 then times the 4. So that's going to be a minus 8. 4x plus 3 all to the power of minus 3. So that's quite close to what we need. That means if I integrate, we'll just take this one slowly. Minus 8 4x plus 3 to the minus 3. I will of course get 4x plus 3 to the minus 2 plus c. That's quite close to what we need. Our original question was this one here, so we just have to then kind of divide both things in by 8, and so our final answer then is going to be the integral of 4x plus 3 to the minus 3. So we need to divide both sides here of this, I suppose, by minus 8. So minus 1 over 8, 4x plus 3 to the minus 2 plus c.